today I need to cover those two topics. One which I had started related to the heat exchange from the human body to the surrounding, and we'll see the more details related with how the heat exchange takes place and how does it affect the performance of human being and what can be done to avoid or reduce the adverse effects related with the too high temperature or too low temperature conditions. And then we will see the mechanical vibration related section, where when the human body is exposed to the different kind of the mechanical vibrations, uh, then the body responds in very different way under the different conditions, and the response of the body can be there right from feeling little headache to the entire body pain to the stomach upset to the complete damage of the nervous system. So feeling the vomiting, like that, there can be number of the adverse effects on the human body when they are exposed to the different conditions. So aware of means being aware of the role effect of vibrations of the human body and how to control that. So these are the two topics about which we'll be talking. So the first topic, as I started yesterday, is about like the heat exchange role, the way by which heat exchange takes place, and the response of the human body. So as you know that due to the metabolic activities associated with the every human being, heat is generated. So even in the rest condition, heat is generated around 1 to 1.5 kilocalorie per minute, and when work is done, additional heat is generated, and which can vary as per the exertion or the kind of efforts which are needed to carry out the work. And the heat generated due to the work being done by the human being, it can range from say 15 to 20 kilocalorie per minute also. So whatever heat is generated, this must be dissipated, otherwise the temperature of the body will start increasing, and the person may feel, or the human being or worker may feel, lot of undesirable effects. So we need to understand really what are the different ways through which heat is generated, and then it is, and how the thermal balance is realized. So heat exchange process of the human body with the environment, as I said, the heat is generated due to the metabolic activities at the rate of 1 to 1.5 kilocalorie per minute, and when the heavy work is done, it can be as high as heat generated. So these are the two sources: metabolic heat and the heat being generated due to the efforts being made by the human body. So whatever heat is generated, this must be dissipated so that the human body temperature is maintained. Okay, if it is not maintained, if it goes either on the higher side or in the lower side, due to the too high heat rate dissipation or too much heat dissipation from the human body, or excessive heat being delivered to the human body, in both the cases it disturbs the thermal equilibrium of the human body, and which in turn depends on what? The metabolic heat. This is one. Okay, so this is heat generation, right? Then the heat being lost by the evaporation, then heat can be supplied as well as transferred away from the body by convection. Heat can be supplied and transferred away by the radiation as well, and the heat loss or generated during the work. So it is mostly generated during the work, and all this should be sum or minus of all this, or algebraic sum of all these constituents should be equal to 0 to have the thermal equilibrium conditions, so that the body temperature can be maintained. So these are the different modes of the heat transfer through which exchange of the heat between the body and the environment can take place, like the evaporation of the sweat, convection through the air being passed through the body, radiation of the high and low range, low wave, short or long wave radiations, then the respiratory the process will be leading to the heat transfer by convection as well as evaporation. Okay, and when someone is standing on the floor, so through conduction also the heat loss takes place. In coming slides we'll be seeing little more details. So this heat dissipation or its preservation, both are important. If the temperature conditions are very low, like it is very cold condition, then heat being generated by the metabolic activities must be preserved so that the body temperature can be maintained. And if excessive heat is being generated due to the either heat is getting transferred to the body from the outside hot weather conditions, or too much heat is generated due to the work, or the heat generated by the metabolic activity. So in the hot conditions, heat must be dissipated to maintain the body temperature. So in both the cases, in order to maintain the body temperature in this band, the heat must be dissipated. And if it doesn't happen, say this equilibrium is disturbed, then the body temperature comes down or it goes up. So when it goes up, the sweating glands activated and the sweating takes place. That in turn facilitates the evaporation, and which in turn helps to lower the body temperature. Okay, so as I have said, the heat goes to or from the body through these different modes of the heat transfer, like convection, radiation, evaporation. Role of conduction is very negligible. Like say through the legs, it is hardly 3%. Okay, convection is contributing around 27%, and evaporation, although it will depend upon the surrounding temperature condition as well as the air velocity. But under normal comfort conditions, this is the situation. Like radiation heat loss 40%, evaporation heat loss 30%, and convection heat loss 27%, and 3% by the conduction. Okay, so that's what you can see in comfort condition. Here the maximum heat loss is there by the radiation, then little bit by convection and the evaporation, right? The role of conduction is negligible. But if the conditions are very hot, then you will see the maximum heat loss is taking place from the body by evaporation, and then heat can be transferred to or taken away from by convection, and heat is supplied by radiation when the temperature conditions are hot outside. That is primarily determined by the wall temperature. Okay, what is the surrounding wall temperatures with respect to wall or air temperature with respect to the human body temperature. Okay, so the relative amount of the heat exchange by these different modes depend on the type of the environment and the surrounding conditions. Okay, like if there is the temperature is high or low, or the air velocity or the humidity in that particular environment. So heat exchange processes are affected by the air temperature, air movement, humidity, and like the wall temperatures will be affecting the heat loss or gain by the radiation. Okay, so now this is just a little elaboration only. When the temperature outside is too high and its temperature is close to the skin or body temperature, that is around say 37 degrees centigrade, so in that case there is no loss from the body by the convection. Primarily the heat is getting received by the radiation, and the heat loss to the surrounding is negligible by convection. So the body temperature starts going up. In that case, these sweating glands activated, and the sweat secretion starts, and that will be coming out through these the pores. So the body temperature begins to rise under such conditions when the temperature of the surrounding temperature is close to that of the body temperature. So that leads to the activation of the sweating glands and evaporation of the so that in turn leads to the secretion of the sweat, and when the sweat evaporates, this will be leading to the more loss of the heat by convection, and that in turn helps to maintain the body temperature when there is a moderate heat conditions. When the temperature conditions are too high, like say above 38 degrees centigrade, so preferred working temperature is this much, that's the dry wet bulb temperature, preferred temperature for work. But when the temperature goes above 38 degrees centigrade, there is a possibility of the heat stroke. And when the heat stroke happens due to the high heat exposure, high temperature conditions, exposure to the high temperature conditions, this leads to the extremely high body temperature. It is 103 Fahrenheit. Red hot dry skin with the no sweating, rapid and strong pulses, vomiting, and the confusion or dizziness. So these are the symptoms corresponding to the heat stroke condition. So obviously we need some kind of the protection. So for protection I will be talking little later. What happens when the body is exposed to the cold conditions? When the body is exposed to the cold conditions, the body responds in very dramatic way. What is that? Like the body, human body stops or decreases the supply of the blood to the skin or to the hand or to the legs to such an extent that these may start feeling cold first, and the reason or the purpose both related with the drastic reduction in supply of the human blood to these remote locations is to conserve the heat. Whatever metabolic heat is being generated, that is conserved so that the body temperature can be maintained. So in extreme cold conditions, body reduces the blood supply, okay, so as to maintain the body temperature by retaining most of the metabolic heat being generated. Okay, if the cold conditions are further harsh, and if the metabolic heat being generated is not high enough to compensate or to maintain the body temperature, then shivering starts, okay, due to the cold conditions. So when the shivering starts, the speed of the hand, fingers and legs and their accuracy, these are two things very badly compromised, and as a result of this, performance of the worker is very adversely affected. So as far as the high temperature is concerned, too high temperature will be decreasing the performance of the workers, but when the temperature condition is very low, in very cold conditions, body reacts almost by stopping the blood supply, and in that case the hand and feet or the skins where the blood supply is very low, skin temperature is reduced, and this causes the loss of speed and accuracy of the hand movement. So if you are doing the fine job, then what will happen, your speed and accuracy of the fingers has come down very badly due to the reduction in temperature of the fingers and the leg. So this will be reducing the performance or efficiency. Say this is an example of the typing work. So when the temperature comes down, say from 34 to 14 degrees centigrade, obviously there will be greater reduction in temperature of the fingers and the legs, and that in turn you can see efficiency, typing efficiency is reduced by 50%. So this primarily happens. So under low temperature conditions, when the accuracy and the speed of the fingers is badly compromised, the fine job cannot be done very efficiently and effectively. So this is the temperature scale which is showing what happens to the different body parts and how the performance is adversely affected with the drop in temperature. Okay, so this is just for the reference. You see the optimal performance is around 32 to 36 optimal hand and finger functions, okay, in 27 to 32 degrees centigrade. like the effects, this affects the dexterity and the precision and the speed in 20 to 27 degrees centigrade. This adversely affects the performance in work with the finer details and reduces the endurance. With the further lower temperature, impaired performance of the gross hand and the finger work. Okay, occasionally pain sensation is felt, and in this temperature range of 10 to 15 degrees centigrade, reduced gross muscle strength, coordination, and the pain sensation. Further lower temperatures blocking the sensory and the thermal receptors of the superficial skin. So below this, you see that below 10 degrees centigrade, you'll see the numbness, manual performance is reduced to the simple gripping, pushing, and rhythmic rewarming. So these are the kind of adverse effects which are felt by the hand and the fingers. And below 0 degrees centigrade, the freezing of the tissues. Okay, so how to protect? So the protection against the cold is somewhat easier. Easier means you can cover the things. So insulating the worker using the suitable insulating material clothing in extreme temperature conditions, that will help to reduce the heat being generated, reduce the heat losses, the heat which is being generated by the metabolic activity. So suitable clothing will reduce the heat dissipation which is being generated through the metabolic activity. So that's how it helps to maintain the body temperature and reduce the adverse effects. And also it is important to protect the legs and the hands to avoid injuries due to contact with the low temperature conditions. On the other hand, dealing with the high temperature condition is more difficult. How? Because the human body will be generating the heat by the metabolic activities and by the work. And if we cover the entire body like this, then all this heat will be conserved within the clothing and the body temperature will start increasing. So it is not advisable to cover the human body completely. Okay, so now coping with the hot conditions is difficult because of the fire hazards. That's one possibility, and heat generated by the human body must be dissipated to maintain the body temperature, and most of the heat generated by the body is dissipated through the hands and leg in such conditions. So therefore it is advised that do not cover the whole of the body unless it is absolutely important. And what will be happening even in such conditions, if it is completely covered, then the breaks will be given very frequently so that the body temperature doesn't go beyond the certain threshold values where people start feeling very adverse effects on the human body. So they will be given very frequent breaks if it is required or if it is important. Okay, so that's how we complete our the section related with the heat exchange from the human body, its effect on the performance, and what can be done to protect the human body from the extreme weather conditions, whether they are too high temperature or too low temperature, hot or cold conditions. Okay, so this is the next topic that is about the mechanical vibrations. Like you must have felt like when the sound at very high volume or you are very close to the speakers giving the sound at very high volume, so you can feel the kind of the waves or the vibrations which are coming due to the sound close to the speakers. And that so how the different body parts feel the vibrations which are coming at the different frequencies, and what happens and how does the human being feel from the medical point of view, from the performance point of view. So most of the time, uh, like say, when the human body is exposed to the different types of vibrations, say what is the types means, that is about the frequency, the vibration, like say of 2 to 8 hertz, and say 0.1 mm, 0.1 mm to say 1 mm amplitude. So depending upon the frequency and the amplitude of the vibrations which are being felt, or to which a human being is exposed, the kind of the experiences, or the kind of feeling, the kind of changes which will be experienced by the different parts of the human body, those will be different. The reason being is that like these vibrations, okay, vibrations will be generated by some source, okay, and that source may generate the vibrations at a very low frequency or at a very high frequency, say 100 hertz, okay. And the human body made of comprises the different parts, like heart, eyeball, head, even legs, spine, and these body parts, arms, all these body parts are connected through the skeleton, through some kind of the tissues, okay. So since the mass and the strength of these tissues through which these are connected with the skeleton or other body parts, so because of the difference in their connectivity and difference in their mass, each body part has the different natural frequency. So since each body part has the different natural frequency, so whenever this natural frequency of a particular body part matches with the natural frequency of the vibration to which it is being exposed, or frequency of the vibration to which it is being exposed, you will see a situation of the resonance will arise. And as soon as the situation of the resonance comes in, you will find that the amplitude increases significantly, and that may lead to the damage to the tissues, deformation. And when it happens, the operator or the worker or the human being who is being exposed to the vibrations, as per the frequency of the vibrations, different body parts will start feeling in different ways, okay. So the particular body part which is experiencing the resonance, that will be feeling some kind of the pain or some kind of uneasiness, okay. Say when the eyeball resonance takes place, you are not able to really see what is coming clearly. Your object recognition system doesn't work effectively, or your response time increases significantly, say as far as the eyeball is concerned. Similarly, when you are reading, you may not be able to read it clearly because your visibility is reduced significantly. Similarly, when your stomach is vibrating, then you will feel vomiting. When the head is vibrating at resonance frequency, you will see that there is a headache, there is object recognition problem, there is so there are a number of issues. Similarly, when whole of the body is exposed to very high frequency vibrations, say when you are sitting in aircraft, so just after the journey of 1 hour or 2 hours, you will feel lot of fatigue. That's very common. So when whole of the body is exposed to the high frequency vibrations, entire body starts feeling some kind of the fatigue or body ache, you will find. When the human body, like say, so the response of the human body to the vibrations will depend upon, of course, the biology, anatomy and physiology. You have already seen all these, like anatomy or the anthropology or the physiology related things. So how strong built is, okay, and the kind of conditions, how strong built of the human being is, so that will decide how much he can resist and how long he can remain stable when exposed to the vibrations of the different frequencies. So vibrations, of course, the source of it depending upon the kind of lubrication, kind of the masses, kind of speed, kind of road conditions. Say if you take the example of car, kind of road conditions. If you take the case of aircrafts, or it is the car or tractor moving on the rough road. So depending upon the system, the vibrations of the different frequencies and amplitude can be generated, and when the body is exposed to these vibrations, you will see the effects maybe at the biomechanic level or at the psychology level. So one may not feel good about. So this is the kind of the interrelation from the ergonomics point of view and the vibrations. So human body, the response of the human being and the vibrations. Okay, now we'll see when the vibrations are transmitted. So these vibrations are transmitted to the human being. There are three ways, like through the localized zone, like the person is holding the drilling machine and hole is being drilled on the wall, so the vibrations will be felt. So the vibrations are being transmitted to the human being through the localized contact. Okay, or when the someone or the operator is standing on the floor, which itself is vibrating, or it is the operator or the human being is sitting or standing on the floor, which itself is vibrating. So through the support. So one is through the localized zone, second is through the support area in the whole body. These vibrations will be given, and whole of the body is exposed to the vibrations like sea or air travel or even the car. So in sitting and standing position, the vibrations can be transmitted to the body through the seats or to the floor, or whole of the body is exposed when journey is being made by air or by sea. So the vibrations can be transmitted in a very localized way, like say through the hand or legs, or whole of the body when someone is standing or sitting in a vibrating system, or whole of the body is exposed to the entire vibrating system. So these are three ways through which vibrations can get into the body. Okay, now these vibrations are of the different frequencies, like say the sound sources and the corresponding. Just for an example, like what you get, what kind of frequencies you get when we use the different kind of the sound sources, say ultrasound, clapping, or so these are, there is a huge range. Dog barking, insects, so they are in very high frequency range. Then electric vacuum sound, mosquito sound, dog whistle. So there are different different sources of the sound and the corresponding frequencies. These may not be harmful unless the decibel level is very high, or you will also see that some of these are harmful as well. So we'll see these in detail in coming slides. Okay, so I was talking of the frequency of the different body parts. Okay, so the body parts like eyeball have got the natural frequency in the range of 20 to 90 hertz. For head it is 20 to 30. It is, I believe it is 80 to 90 hertz. It's in high range. For head it is 20 to 30 hertz. For shoulder it is 4 to 5. Chest 10 to 50. Forearm 16 to 30. Arm, upper arm is like say it is 4 to 5 to 10. Spine, stomach and legs. So effect of the vibrations depends on the frequency. Okay, so if the frequency of vibration is matching with the frequency of the body part, then you will be having the resonance condition. And when this resonance condition is realized, or it occurs under certain set of the conditions of the vibrations, and which is matching with the natural frequency of that body part, then it will be leading to the tensions and deformities in very localized way, and that causes the pain in chest, abdominal and head. So the headache, abdominal pain or in the chest pain, it can be experienced when the natural frequency of the body parts matches with the frequency of the vibrations, and that primarily happens due to the tension and the deformation experienced by these the body parts. Okay, so let me erase this. So this is like in standing and in the sitting postures, the resonance frequency of the different body parts is given, say for legs, for knees, for foot, for whole of the body. So if you see the resonance frequency of whole of the body in general, it is in 4 to 7 hertz band. Okay, and those which are body parts which are having the frequency in the range of like say 4 to 8 or 1 to 3 or like this. So basically these are the low frequency vibrations which are considered to be more troublesome as compared to the high frequency vibrations. During the driving, during the vehicular operations, mostly you will see that these are the low frequency vibrations which are experienced. And so when the body vehicle is moving on the rough road, or a lot of vibrations are coming during the operation of particular vehicle, and if they are of the low frequency, you will frequently see that after a short journey by taxi or by the bus in a rough road or even in the hilly areas, you will start feeling fatigue too early. That happens primarily because of the kind of low frequency vibrations which are experienced, and that in turn will be leading to the very common resonance conditions to these body parts. So one starts feeling fatigue in very early stages. Okay, so what happens when the body is exposed, and how the human being starts feeling about when the exposure to the vibrations is there for a little longer period. There may be anxiety, loss of interest, loss of appetite, headache, the loss of visibility is also there. Reaction time increases. Reaction time is about, like, normally the human being, say if it is responding in a half a second in a situation, then under such conditions he may take 1 second or so. Pattern recognition is also adversely affected when exposed to the vibrations. So basically these two are related with the eye, these three are related with the eyes, this is related with the abdominal problems, and this is related to the headache and anxiety. So now you see what are other issues and the kind of the vibration conditions when they are experienced. So respiratory complaints are observed in this band 4 to 8 hertz. General discomfort again 4 to 9 hertz. So this is low band frequency. Low frequency is really harmful and very undesirable. Abdominal pain 4 to 10, chest pain 5 to 7, jaw resonance 6 to 8, back pain 8 to 12 hertz. Okay, there is a constant urge to urinate or defecate is 10 to 18. Headache 13 to 20, muscle tensions 13 to 20, and speech disturbance, one may not be able to speak properly, so in the band of 13 to 20. So below 10 hertz low frequency vibrations resulting from the travel of the vehicle or the machine being operated on the rough surface. So obviously the vibrations will have the two component, one is horizontal and another is vertical. It's the vertical component that is considered to be more harmful as compared to the than the horizontal one. So now you see the kind of vibrations to which a human body is exposed when one is sitting in a car. So vibrations can come from the rough road, they will be of the different frequency and amplitude. Engine vibrations, the vibrations from the windshield, then vibrations, driver seat vibrations. So there can be a different kind of the vibrations and different frequencies of the vibrations which can be experienced by the passenger or the driver when the vehicle is being driven, and that in turn can lead to the different kind of the undesirable feeling in the driver or in the passenger. So below 10 hertz, below 2 hertz, the body responds to the vibrations like a dead weight, so it doesn't affect the things much. 2 hertz, above 2 hertz, the relative movement between the body member and organs due to the resonance effect with the skeleton and connecting issues. So this causes the pain because of the tensions and deformations. Human body resonance occurs between 4 to 8 hertz, and that lead to the considerable amplifications of vibrations between the buttocks and upper region of the body, leading to the severe discomfort. So the legs prevent the transfer of the vibration in a standing position. The task needing the steady and precise control of the footwork or steering are likely to decrease with the vibration. So those where you need precision, better control, those activities are compromised when the vibration is experienced. This is a typical example actually I have shown. The reason behind this, the vibration is so intense, high amplitude, okay, and the high vibrations. It is so intense that it can damage. Here you see, oh yeah, he is using gloves in order to reduce the possibility, reduce the vibrations effect. If there is no such condition, like say the rocks are also, hole is drilled in rocks, in concrete, so very high intensity, high amplitude, high frequency vibrations experienced, when the body experiences this, it can lead to the damage to the nervous system also, so that can lead to the death of the human being. So what can be done to control the vibrations or these high frequency vibrations? Provide cushions and good suspension, flexible hand gripping, anti-vibration devices like rubber springs, proper lubrication, proper balancing, and using the dynamic vibration absorbers. Okay, so that's all about the vibrations and the heat exchange from the human body as far as the ergonomic is concerned. In the next lecture we'll be talking about the two remaining portions, that is about the light requirement, that is one, and the design of uh, control devices, display and control devices, design of display and control devices. So additionally there is one more that we have to cover, is the locating lo locating the controls, where the controls need to be located. Location of the control, certain principles are followed. Similarly, for designing the display and control devices, also certain principles are followed. And what are the kind of light requirements for the different kind of activities? So about that we'll be talking in the next lecture. Okay, so that's all from my side for the day.